right, let's get started. Hello everyone, my name is Francisca Tan. I'm the Product Management Lead for Tessent Embedded Analytics as part of Siemens EDA. And today I'm going to talk about a new end-to-end solution we have for functional monitoring called Tessent UltraSight. So let me start with the challenges and trends. So with the dawn of AI and high-performance compute and the shift towards multi-chiplet technology, systems are getting more and more complex. And with that, the debug complexity is also increasing. And silent data corruption and timing-sensitive bugs continue to be hard to root cause and also to reproduce. So this is where in-depth visibility of what is going on in the system can really help in terms of pinpointing the root cause of the issue. But it's also important to note that it's not just about the processor core, okay? It's also about what is happening in the different parts of the SoC itself. So this is where full system level functional monitoring can help. And when I say functional monitoring, what I mean is that being able to monitor or observe if the system is behaving as expected. And for example, one good example of functional monitoring beyond the processor core is maybe you want to monitor the bus transactions that are happening within the system to give you more visibility into what's happening. Or maybe there's specific hardware signals within the system itself that you want to have added visibility to know what's going on. But with functional monitoring, one question you might have is, okay, I have all these data, I'm monitoring and gathering all this data about my system behavior. That is going to be a lot and that's going to take up bandwidth. So this is where efficient functional monitoring is important. You need to think about steps to mitigate that high bandwidth issue with functional monitoring data. So things like maybe you only monitor the data that is important to you, or you only monitor the data around a specific event. And this is where cross-triggering capability becomes very helpful and powerful as well. And you also have to think about, what's compatible in terms of the industry standard interfaces. For example, how are you going to transport that data out? Are you going to use JTAG or USB or over PCIe? So now I'm going to talk about our new end-to-end solution that is called Tessent UltraSight. It includes configurable hardware IP monitors, functional monitors that you can embed throughout your system on chip. And these monitors are pre-verified and silicon-proven. We also provide a new tool, which we call EA Builder, that can help design engineers to generate a subsystem using these functional monitors as well. Therefore, you are actually generating a debug and trace subsystem, if you will, that you can easily integrate within your system of chip. And with this generation of subsystem, it also comes along with the test bench for that subsystem. It also comes with the UVM verification IP that is IEEE compliant. In terms of software, we provide C++ and Python APIs that you can use to communicate with the functional monitor IPs within the system to gather data. We support filtering and cross-triggering mechanisms. And we support multiple interfaces as shown here in this slide. So let me talk a little bit about the configurable IP monitors. So this slide here shows a collection of the embedded IP monitors that we have, that we include as part of Tessent UltraSight, which provides system-level debug and functional monitoring capabilities. And there are different types of functional monitors monitoring different aspects of the SoC. For example, we have monitors that work closely with the processor. So for example, obtaining processor trays, but we also cover up to a range of monitoring bus transactions. We have logic analyzer capabilities called the IP that we have called status monitor. We also provide visibility into the memory in the SoC itself. We also have IPs that can help with minimally invasive logging mechanisms as well. And if you require more details about this, please feel free to stop by our booth at the back where our product engineer, Aaron, can tell you a little bit more about that. Moving on to EA Builder, our new subsystem generation tool. The snapshot that you see on the right, it basically shows the GUI interface and also the Python-based function classes that are available as part of this tool. So for example, for users who already have an existing flow that is scripted, rather than using the GUI, they may prefer some functions or classes that they can easily integrate within their existing flow. So with this tool, all the user needs to do is to select the IPs that they want to form as part of the subsystem. The tool also allows you to configure the parameters and interfaces for these hardware monitors. And when you click the generate button, it automatically adds the communication infrastructure and the interfaces of your choice as part of that subsystem generation. It also generates the test bench files that will go with the generated subsystem. As I mentioned before, we also provide a UVM verification IP for our IP monitors. And this really helps in terms of providing effective and comprehensive verification, whereby it helps the verification engineer verify that the UltraSight modules are correctly connected to each other. As I've mentioned before, it's IEEE compliant. The integration environment also comes with virtual interfaces and example tests as well. Now let's talk about software. So UltraSight includes easy-to-use C++ and Python APIs that you can use to do several things when you're communicating with the IP monitors. For example, you can do runtime filtering, you can do tracing for different types of monitors. You can also, for example, some monitors have counters where you may only be interested in collecting the performance metric rather than the raw message itself. In order to save bandwidth, that is also possible. And also there are APIs that could facilitate, in terms of cross-triggering, you have the ability to specify and define the event that you want to cross-trigger based on. So the snapshot on the right is an example of the Python APIs that do that kind of cross-triggering and filtering as well. So the APIs really provide the flexibility in terms of software environment for the users of functional monitoring. The users can continue to use their favorite IDE of choice. They can build C++ and Python applications for automated data acquisition and functional monitoring and analytics as well. And for users who are used to a specific third-party debugging environment, such as Lauterbach, they can continue to do so because Lauterbach Trace32 solution is compatible with the Tessent embedded analytic monitors. So we have a live demo at our booth. I won't go into much detail about this, but you can visit our booth just right at the back, and our product engineer can walk you through the demo that we have. But in this demo, basically, we utilize the bus monitors to capture some statistics and data that will give you the bus utilization metric. And we are able to plot, in terms of the trends as well, based on the data that's collected. So I know I've given all of you quite a lot of information, and I only have 10 minutes, so I'd like to summarize at this point. So if there's anything that you need to take away, it's just 3 things to remember. First of all, it's when it comes to complex debugging, because of complex systems, it's not just about the processor core, it's also about the entire system. And secondly, added visibility into what's happening within your system definitely will help with your debug and also allow you to take actionable insights. And the third of all is that we have that solution for an end-to-end system-wide functional monitoring. It's called Tessent UltraSight. So please come and talk to us if you need more information. We also have a poster right at that area there, which is done by my colleagues. So if you're interested, we can meet at the booth or the poster where my colleague can run you through the contents of the poster. And if you need further information, please check out our website. The QR codes are available. We also have a case study that we did with Meta, who used Tessent Embedded Analytics as part of their debug infrastructure, and you can watch the video that was presented by them as well. All right, thank you very much.